In today's episode we will add another requested feature, and that is the implementation of a weight system. For this video and probably for the next one I imported two textures, on the one hand the weight icon and on the other the gold icon. You will find the download link to them in the video description. Also, later in this video we will take a look at adding particle effects, and for that I added the infinity blade effects to my project. You can download them for free on the marketplace. But now let's get started. First thing we'll have to do, if we want to give all of our items another attribute, is to go inside of our blueprints folder, under structures, and open the s-item info. Now we'll create a new variable, and that will be the weight. Make that a float or an integer, as you like. Save it and close it. Now we'll have to go to our item classes, open the BP master item, and compile it, since we made changes to our struct here. We will also have to set the default values for that. So let's go to our hero sort, give it a weight of 20, compile and save. Then to our item health potion, give it a weight of maybe 0.5, compile and save. The map can have a weight of 1. And our ring maybe 2. Compile and save. We also have to change our inventory widget to display our current weight and a weight cap. So let's go to our widgets folder, open the inventory widget here, search for a border and drag that on top of our vertical box. For that border we will set the padding to 0, expand the brush color, set the RGB values to 0 and the alpha to 0.6, just so it appears in the same color as our top border here. Then search for a horizontal box, add that to our border. In that horizontal box we will start with a size box. We can give that size box a bit of padding to the left, maybe 5 pixels. Set it to horizontally align left and vertically to the center. Then we can give it a width and height override of 50 by 50 pixels. After that we will get an image and drag that on top of our size box. That image will be our weight icon. And the last thing we'll need is a text. So add that on top of our horizontal box, vertically align that to the center and horizontally to the left. Also give that some padding to the left, 7 pixels maybe. Let's also decrease the font size to 16 maybe, and set it to regular. Give it a name, something like weight text, and make that a variable, since we need to access it later. You could also type in some default text, something like 25.0/250.0, so you can see how our weight will be displayed afterwards. Alright, that's it for our inventory widget. We can also display the weight of an item in the tooltip widget, so let's do that. Open up the detail widget, and on top of that vertical box we will add another horizontal box. Same as we did before, get a size box, set that to align center and left. Width and height override this time could be 60 by 60, just a bit bigger version of the icon. Add an image. Select the weight icon, then get a text, add that on top of the horizontal box, vertically align that to the center, horizontally to the left. Let's decrease the font size again, something like 18 should work, and maybe also set the type to italic. And in the details widget we will display the weight of the item, and if it's stackable we will also display the total weight. So if we have 50 health potions that all have a weight of 0.5, we will show 25 and in brackets the weight of a single item. So for the default text, type in something like 50.0, then in brackets 0.5. And you can see how that will look. Maybe also give it a padding to the left of 7 pixels. And you have to make sure that you give it a name, weight text, make it a variable again. Now let's compile and save, go to the graph, And in our update function, before we return, we will get the wait text, set text, and for the in text, we will select, connect the return value to the in text. The index will be our can be stacked boolean and the condition that our amount is greater than 1. Connect the end to the index. If that is false, we will only display the weight. So off of the weight, search for to text. And we will have to expand that and change some settings here. So the minimum fractional digits should be 1. So that means when it's 0, it will display 0.0 and not just 0. And the maximum fractional digit should also be 1. Also change the rounding mode to half to 0. Then let's connect the return value to the false. And for the true, we have to right click, search for format text. Now for the in format, type in curly brackets, total weight, close the curly brackets, then open a usual bracket, open a curly bracket, type in single weight, close the curly bracket, and close the normal bracket. Plug in the result for the true. The single weight will be the weight to text, so plug that return value in for the single weight. And total weight, we will get our amount, convert that to a float, then search for times, float times float. We will multiply it with the weight, and then search for to text. Again, rounding mode half to 0, and minimum and maximum fractional digits to 1. And then connect that to the total weight. Let's compile and save. We can close the detail widget, and now we can work inside of our BP inventory. First off, we will add some variables. The first one will be the current weight. Make that a float. Add another one that will be the overloaded cap. So which means that if our current weight is greater than our overloaded cap, we could, for example, slow down the player. Add another variable, and that will be overloaded question mark. Should be a boolean. After we compiled and save, we also have to enter a default value for the overloaded cap. I would choose 250. Let's add a function called update weight, and we'll get our inventory widget. Search for the weight text, set text. For the in text, we will search for format text once again. This time it will be curly brackets, current weight, close the curly brackets, slash, open another curly brackets, type in weight cap, close the curly bracket and hit enter. For the current weight, we'll get the current weight, search for to text. Again, rounding mode should be half to 0, and minimum and maximum digits should be 1. Let's copy that to text node, paste it, this time plug in the overloaded cap. Return value will go into our weight cap, and the return value of our current weight into the current weight. Then connect the result to the in text. After that, let's copy over our get weight text, and we will set color and opacity. Off of the in color and opacity, search for make slate color, and then off of the specified color, we can search select color. Our pick A will be the condition that our current weight is greater than our overloaded cap. Connect that to the pick A. If that is the case, we will change the color to red. If not, our text will remain white. After we set the color, we can return. Also, we have to call that function before we add our main widget to the viewport. So let's go to the event graph. On event begin play. After we updated our health bar and before we added it to the viewport, let's call the function update weight. Now if we compile, save and play, we should see our weight. 0.0 and our cap is 250.0. Before we proceed, let's minimize the inventory and let's go to the top-down character. In here we will need two new functions, or you can also make that custom events, but I will choose functions. First one will be on overloaded. And when our player is overloaded, we can get the character movement. If you select that and search for max walk speed, that value defines the speed with which we are walking around. Currently it's set to 600. So when we're overloaded, we will search for set max walk speed and set that to 300 maybe. After that, return. Let's duplicate the function and call that on overloaded end. So when we're not overloaded anymore, we will set it back to 600 and then return. Compile and save. You can close the top-down character. And in our BP inventory, let's add new functions. First one will be add weight. And it will have an input that is the amount to add, which will be a float. So what we do is set the current weight, also get it. Then we'll add the amount to it and set the current weight to the result of that. After that, update the weight. And then we will branch. And the condition will be that we are not overloaded at the moment and that our current weight is greater than our overloaded cap. So connect that to the condition. If that is the case, we will set overloaded to true, get the top-down char reference and call on overloaded. After that we return, and if it's false we directly return. Now let's right click, duplicate that, call it remove weight. This time we won't set it to the amount plus the current weight, but to current weight minus the amount. And we will check for the case that we are overloaded and that our current weight is less than or equal to our overloaded cap. Connect that to the end. If it's true, set overloaded to false again and call on overload end. After that we return. The next two functions are completely optional and you don't need them, but I think they make it a bit easier when we call our functions later on. So I will add a function that is called add weight for item. We'll have an input that is the item. Change that to BP master item class, and it will have the amount of items, which will be an integer. Now what we'll do is get the item, get class defaults, break the item info, expand so we have access to the weight, then get the amount, convert that to a float, multiply the weight by our amount, and then simply call our add weight function. After that return. Let's duplicate that function and call it remove weight for item. The only thing we'll have to change is that we don't call add weight, but remove weight with the amount. Okay, now our functions are set up. However, we do not call them yet. So for the add item, you could either go into the add item internal function, or the usual add item function that is called from outside of our blueprint. Let's go to the true path of the show obtained message. And after we add the item internally, we check whether we are successful. If true, we show the obtained message. But right before we do that, we will add wait for item. The item will come from our input item class, and the amount will be our in amount minus the rest that wasn't added. Connect that to the amount. After that, we show the obtained item message. Now for the false path, after we add the item internally, let's branch off of the success. If it's false, we will go to the return node, and you could unplug the success and just leave it unchecked, because we know it's false then. However, if we were successful, we will call add wait for item again. Class comes from our in class again, and the amount will be our in amount minus the rest. Connect that to the amount. If that function is becoming a bit confusing for you, you could also, right before you go into the branch, promote that in variables to local variables, so you don't have wires all over the place. After we added the wait for item, we return successful this time, and the rest comes from our add item internal function. Compile and save. Another thing we'll have to do is to go to our remove item at index function and remove the wait here. So if our local amount that we're trying to remove is greater than the amount at our local index, before we set the array element, so let's move that over a bit, we will remove wait for item, and now we will get our slots array, get from it at the local index, break it, connect the item class to the class to remove, and the amount to the amount, because if we're going to this path of the branch, all of our items on the slots will be removed, so we can plug in the amount that were on the slot before for the remove wait for item. Also make sure that you call that function before setting the array element, because otherwise you don't have access to the amount that was there before. For the false path, we can copy over our function. Again, call that before you set the array element. The item class comes from our break as inventory slot here, and the amount will just be the local amount that is subtracted afterwards. Now compile and save. You can close the inventory. Let's actually alt and drag our pickup actor here, change the amount to 10 so we have a chance to become overloaded. Now when we get our 50 health potion, you can see that the total weight is 25 and that each one of them has a weight of 0.5. Let's remove maybe 3 of them. See, we're at 23.5. If we remove all of them, however, we're at 0 again. Let's get our hero swords, and here we only see the single weight. If we get 10 other of them, now you can see that our text changed its color to red and that we are slowed. If we throw away a hero sword, for example, you can see the text becomes white again and we can move around as we did before. To make clear that the player is slowed because he's overloaded, you could also add a particle system, and for that we will go to the Infinity Blade effects and search for p underscore ice underscore freeze motion. Right click, duplicate that, and call that our slow effect. Now search for this slow effect and move that to our inventory system folder. Now clear the search bar here. Let's create a new folder called effects. Make sure to spell that correctly. Let's move the particle system inside of the folder. And if we double click to open that up and restart, you can see that it doesn't look properly for slow animation. However, particles contain different emitters that you can see here. for example the ice shards and then the loop and linger. For the slow animation we only want to see the dust and the small white particles flying around, which are our last two emitters. So to turn off the other ones, you can just uncheck the checkbox over here for the ice shards and for the fast. You can see that they're grayed out and that they won't be shown anymore. Save that. Also have to attach that to our top-down character. So with that particle system selected, open our top-down character. Go to the viewport, add component, and here you can see particle system and in brackets the slow effect. Add that and drag that on top of our mesh. Also we don't want to show it the whole time, so we can scroll down here and under activation uncheck auto activate. Then in our onOverloaded function, before we return, we will drag in the slow effect and activate that. Then in our onOverloaded end, we will drag in the slow effect and deactivate it again. Now compile, save, and let's play. You can see that there is no snow around us right now. Now you can see it moving behind us and the player will know that he's slowed because of the overweight. If we throw away our hero sword, you can see that the particle system doesn't follow us anymore and that we can move around as we did before. Alright, that's it for today's episode. See you in the next one.